This video is going to cover question number 1978b2. And as I look at this diagram, I have to think about how I'm going to set it up. But as I look at this diagram, I am reminded of some problems that we did in the kinematics unit. So I think I'm going to need to go to some kinematic equations, find those that might apply. Because remember when we did this in kinematics, if this mass has a velocity, initial velocity, that initial velocity is going to be maintained. It never is going to change unless we have something like air resistance. But it says it has a constant speed, so really that initial velocity is never going to change. Now what is going to change is the velocity in the y direction, because eventually it's going to hit the ground and stop, for one, and so it only has so much space to go. And so in this unit, we had to think about, okay, I have to break this up into my y direction and my x direction. So that's what I'm going to start with. The first part of the problem I'm going to start with is the y direction. And so as I look at this problem, they tell me that my y is actually called h. So I'm going to stick with what they're calling it. They're calling it h. Its initial velocity, well, in the y direction, its initial velocity is 0. I know that it says v sub 0 up here, and it is the same notation, but in this case, this is actually 0. There is no initial velocity in the y direction. Then we have 1/2 at squared, so we're going to put in 1/2 times g and then t squared, and we are trying to solve for for t. The reason that I'm leaving it a g is because they say in the problem to leave it as a g. So I'm not going to plug in 10 or 9.8. I'm just going to leave it g. But the reason I'm doing this, back to kinematics, is that I need to solve for time. And so I need to start rearranging my equation so that I get it solved for time. So when I rearrange my equation, I'm going to multiply times 2. I'm going to divide by g, and I'm going to take the square root, and here is my new time. This is the time that I'm going to use in my x equation, because how far it can go in the x direction is dependent upon how much time it has in the y direction. And so that's the t I'm going to use here. Now in this case, in the x direction, I talked about this at the very beginning, there is no acceleration, because it maintains the same velocity the whole way. So there is no acceleration. So all we have on this problem is we have the initial velocity times the time, which we just came up with. We need to determine d. So instead of calling this x, I can call this d. My velocity is the initial velocity, and my time is what I just figured here. And because it says to determine it in terms of these variables, I'm looking what I have those variables, I'm done with part A. Part B, the block sticks to the toboggan, which is free to slide without friction. Determine the resulting velocity of the block and the toboggan. This is going to be a momentum problem. And so initially, we have M1, that's the block, so that's M1, or just M, let's call it M1. It has a velocity, and it's going to collide with the toboggan, which initially is just sitting there, so that's a 0. Then on the other side, they stick together, and when they stick together, then they have the same velocity together. That's the v sub f. And so all I need to do for this problem is determine the velocity. So I need to solve this for v. I'm just going to divide both sides by m1 plus m2. And so when I divide by m1 plus m2, this is what I get for my final velocity.